All right, you all are welcome back to my channel, KT Physics. Now, from the last class, I was talking about fundamental quantity, and I gave an acronym for you all to what memorize the fundamental quantity we have. I said metal. As you can see, we have M to be mass, we have E to be electric current, we have T to be time, T also to be temperature, we have A to be amount of substance, we have L to be length, and we have another L to be luminous intensity. And I have in front of them here their SI unit. So we're going to be using all these to solve derived quantity. Now, for derived quantity, for derived quantities, these are dependent quantity that they need two or more subtraction or division or multiplication of what fundamental quantity to make what their quantity stand. They are all called derived quantity. Now I'm going to be solving some example. Why do we need this knowledge? Now, a lot of students concentrate more on dimension analysis and they forget about derived quantity. And the knowledge of derived quantity will make you fly better when it comes to what? Dimension analysis. So I want you all to stay tuned and learn from this. Now let us see. We have the first one, area. From your textbook, you will see it there, length times breadth. We have that one, the basic units for this. Because at the course of this class, we're going to be seeing the difference between basic unit and SI unit. So the basic unit for this is what? Meters and meters. Using the knowledge of indices, we have this as what? Meters square. So let us look at the next one, volume. We have it as length times breadth times height. So we have the basic unit to be what? Meters times meters times meters. From your indices, you have it as what? Meter cube. All right, meter cube. Now, let us look at another one, velocity and also speed. But we can just look at velocity, which is what? Displacement over time. In terms of speed, we have this as distance. So the basic unit here will be what? Meter over s. So whenever s is coming up, because the power of s here is 1, due to your indices, you have it as what? ms minus 1. As simple as that. Ms minus 1. Same thing done to what? Acceleration. Acceleration. So we have it as what? Velocity over time. And the basic unit for this is what? For velocity, we have it as ms minus 1 over what? The time is what? Seconds. As you can see, I'm dealing with basic units. So we have it as what? M over s divided by s, which is what? M over s times 1 over s, which is m over s squared. You can also write it as ms minus 2. So now, another very key quantity that we look at, force. Under Newton's law of motion. Force is what? Mass times acceleration. Now, what is the basic unit of force? A lot of students will say that Newton. You are very correct. Newton is just the standard unit for force. The basic unit, let me write it here. The basic unit for force is not Newton, but the standard unit for force is Newton, which is what? N. But the basic unit for force there will be what? For mass, we have kilogram, and we have already solved for what? Acceleration, which is what? ms minus 2, as you can see. So the basic unit for force is kg meters per second square, but not Newton. Newton is the what? The standard unit, SI unit. is different from basic unit or fundamental unit. So as time goes on, I'm going to be doing a lot of simplification when it comes to what the derivation quantity. All right, so let us look at what 6. I will take pressure, and pressure is what? Force over area. Now, what is the SI unit for pressure? The SI unit for pressure is Pascal. Are you getting me? Or it can be what? Newton per meter square. But the basic unit is different. So the SI unit is what? Pascal. You are very right. Or Newton per meter square. The SI unit, standard unit. But the basic unit here will be what? What is the basic unit for force? You have what? Kilogram ms minus 2 from what we did the previous class, from what we just finished now. So we have what? Area is what? Meter square. So we can cut out this. We have what? kg s minus 2 over m. Now when you bring this one up as what? Indices, you have kg m minus 1 s minus 2. So this is the what? Basic unit for what? Pressure. Why this is the what? SI unit. So please don't mix it up. So let us see another one that students might find difficult. 7. Let us look at work done. Work done. What is work done? Force times distance. Now you will notice I am trying my possible best to make sure I give you quantities that have their SI unit and also that have their own basic unit. Like work done, the SI unit for work done is in joules, J. While the basic unit is what? The basic unit is what? For force. We have kg ms minus 2 multiplied by distance again, m, which is what? kg m square, m times m is m square, s minus 2. That is the basic unit for work done. Now, let me do the last one. Young modulus. Now, Young modulus can be, is actually the resistance of a material for what? To be bent or to actually undergo deformation. The resistance of a material to resist deformation. So we have it as what? The what? Tensile stress over what? Tensile strain. Now in this case, we have this as what? Now, what is the SI unit for Young modulus? You can take the SI unit for Young modulus as Pascal or newtons per meter square. But that is not it. So if we break this one down, what do we have? We have stress to be what? Force over area. And we have what? Strain to be what? Extension over the original length. And you will say that what this is what is the SI unit? The basic unit rather. The basic unit for force is what? Kilogram ms minus 2 over what? Meter square over meter. So when we cut out this, that is why we say that what? Strain is dimensionless. So we have this as what? Kg ms minus 2 over m square. Cut it out, you have what? Kg m minus 1 s minus 2. They can ask you in your OBJ question of which quantity have the same basic unit. You notice that what? Young modulus have this basic unit, and what again? You look at what? Your pressure also have the same basic unit. So the beauty about this basic unit under derived quantity is for you to know how to simplify all these quantities in terms of what? fundamental quantities, in terms of their fundamental unit, which is what the basic unit that we are talking about. Now, in the comment section, you can drop more quantities that you want me to what? Derive for you using the basic unit. Thank you very much.